human tissue samples, you see more T cell infiltration. So in the young human, you see few CD3 and CD8 positive T cells, but in the old, you see more, and that is quantified here. Switching gears a bit, one of the most intriguing interventions in the aging space that's gotten a lot of press attention because it's kind of vampire-y and captures the public attention is heterochronic parabiosis. So you take the circulatory systems of an old and a young mouse and you link them such that they share blood. The old mouse gets younger, the young mouse gets older. The young mouse gets more old than the old mouse gets young, which indicates that there's actually more bad stuff in the old blood than good stuff in the young. A lot of this work was pioneered in the Bay Area at these institutions, and some of it is being taken forward by this Spanish blood products company, Grifols, now. And they recently announced some compelling data, not that recently, over a year ago, I guess, data finding in Alzheimer's disease that if you actually do plasmapheresis, you scrub out the blood and you just replace it with saline plus albumin, a blood component, it actually works quite effectively. One of the largest effect sizes we've seen, even in moderate dementia patients. So not most Alzheimer's trials are in mild patients. These are actually in moderate patients. And we're seeing a pretty decent spread in the data there. So it's a 60% reduction in progression, even in moderate AD. This comes out of the work of primarily Irina Conboy and Michael Conboy's labs, as well as Tom Rando and Tony Viscore's lab. Plasmapheresis, you scrub the blood. It's kind of like bloodletting, which has been done for millennia. There may have been something to it, but you replace the albumin. Sadly, this is not one single profitable drug, a pill you can pop or an antibody you can inject. So pharma hasn't really paid a lot of attention to it because it's not scalable, it's not really patentable, but thankfully Grifols is. And by the way, I do own stock in Grifols, although not very much. Okay, so coming on to the amyloid hypothesis in Alzheimer's, I have a very substantial bee in my bonnet about the amyloid hypothesis, and hopefully you'll see it's for good reason, because this flawed belief, this dogma forced upon the field for about 30 years has kept new therapies away from dementia patients, including a member of my family for 30 years, right? So let's look at the sad reality. In this time period, there were only 2 mechanisms of action drugs approved versus all of these failures. So pretty much everything has failed. In Alzheimer's, there are about 250 trials that got into phase 2 or phase 3 that failed, and only 2 drugs that were approved. And by the way, these drugs, donepezil and memantine, they barely work. They slow the rate of progression a little bit, but they have bad side effects. So we cannot declare victory on the basis of those 2 drugs. So why would this happen? Why would there be such a consistent rate of failure in Alzheimer's versus other clinical indications? One, the paradigm is wrong. Most of these drugs that have been tested are reliant on the amyloid hypothesis, and we'll define what that is in a minute for those that are not aware. Another is that we're simply intervening too late. By the time memory becomes a real problem for which you seek treatment, the pathology is too far gone. You're already starting to lose neurons at that point. And they're also not stratifying patients based on the Alzheimer's subtype. So AD is not a single disease. There are multiple causes. It's just lumped together as one thing, presenting as dementia and cognitive impairment. We'll come to that later. So sporadic AD is not a single disease with a single cause. There are genetic forms of AD, but they're like 1% of the actual population of people with AD. Lumping them together, they're overlapping pathologies based on just a memory phenotype. There's no biochemical basis. People say, oh, it's A beta or tau presence in the brain, but newsflash, most clinicians are not checking A beta and tau levels in the brain of patients. And when they do check, they find that there's a pretty weak correlation between cognitive decline and these aggregates. So it's a form of dementia diagnosed with memory tasks. There are multiple subtypes based on the work of people like Dale Bredesen, who I'll talk about. One is a type 3 diabetes, CNS insulin resistance. It can also result from mitochondrial damage, glucose hypometabolism, you can't burn fuel, and then IDE, insulin degrading enzymes. So when your insulin level is high, IDE is busy degrading insulin. and it cannot degrade this other junk that accumulates in cells, including amyloid beta and other proteins. Neuroinflammation we talked about can be caused by undiagnosed traumatic brain injury, poor sleep. Sleep apnea is a big one, failure of the lymphatic system to clear things out. Pathogens, blood-brain barrier leakiness, and ApoE44 is a major risk factor for Alzheimer's, and it actually enhances the inflammatory response. Can get into that in the Q&A if you want. Also, exposure to toxins that are not commonly checked for. Mold toxins like aflatoxin, a super ultra potent DNA damaging agent. Metals like mercury from dental amalgams, pesticides in the food, industrial chemicals in the food and water, etc. Loss of trophic support. So we have these pro-growth and pro-cognitive factors like brain-derived neurotrophic factor and nerve growth factor, and also neuroactive steroids, pregnenolone and estrogens are very important. And this is one reason why menopause is quite commonly inducing cognitive decline, and why women have about twice the risk of Alzheimer's as compared to men, unfortunately. That you actually have vascular dementia, not whatever Alzheimer's dementia actually is. And this can be caused by a lack of nitric oxide, cyclic GMP, and Krebs signaling. Krebs is the master regulator of memory and learning, and they're working with a group with a drug that enhances this activity. And just as a side note about nitric oxide, one of the reasons you want to breathe through your nose is because there are cells in the nasal cavities that produce nitric oxide. Nitric oxide is a very important neurotransmitter, but it's also a vasodilator, and also a antimicrobial agent that is important for lowering your blood pressure and increasing perfusion, blood and nutrient perfusion into tissues, which declines with age. So always breathe through your nose whenever possible. And there's certainly other subtypes, and they're all interlinked. You can have multiple of these problems. A lot of this is based on the work of Dr. Dale Bredesen, who's a neurologist and the founder of the Buck Institute for Research on Aging, which is the largest private aging research institute in the world, where I previously worked. He has set up a number of clinics and this protocol that has been used all over the world now. And it is the most effective intervention for patients with Alzheimer's disease, better than anything known. And we'll talk about that in a minute. So Alzheimer's, it turns out, is preventable. The dogma in the field, amazingly, is that it's not preventable with any kind of intervention. This struck me as absurd because poor health accelerates aging, and aging is the main risk factor for Alzheimer's. So why would it not be the case that if you slow aging, you can actually slow your Alzheimer's risk? Furthermore, Alzheimer's has increased out of proportion with longevity gains in the population, so there are modifiable risk factors. So if you slow aging, hopefully soon with drugs, in addition to diet and lifestyle, you should be able to slow Alzheimer's, and check out these references for more evidence. So the amyloid hypothesis, people are now saying it's failed. Correlation is not causation, and the correlation wasn't very strong to begin with. So blaming A beta for Alzheimer's is like blaming the firefighters for the fire. Yes, they often, but not always, coincide in time, but maybe the firefighters and the A beta are actually trying to solve the problem. They're there to try to help out. And it turns out that A beta, like most proteins in the body, didn't evolve to cause us problems. Every protein and gene evolved to serve a function that promotes health, or at least promotes reproductive fitness at the very least. So these drugs have failed because they're mostly based on the Alzheimer's hypothesis. 80% of the drugs have failed. Many other drugs have been tau focused, and I will submit that tau is not the cause of sporadic AD either. Wasted billions of dollars over 30 years. I strongly recommend reading this article from Stat News in 2019, how prominent academics suppressed alternative theories and counter evidence against the amyloid hypothesis, including Dennis Selkoe at Harvard. Definitely read this because it's a great masterclass in how academics can enforce dogma even when the evidence is not in their favor, how there's a lot of bias. Scientists are not paragons of rationality and enlightenment. They are, opinionated and political and corruptible and prone to error as many others. And Max Planck, the great physicist, once said that science advances one funeral at a time. So maybe A beta is not the bad guy. Maybe it's actually good. Maybe it's, by one theory, functioning as an antimicrobial peptide. So it's in some dementia brains, but not all. Many people have high A beta plaques, but no dementia. Correlation is weak. Drugs that remove A beta from the brain effectively, like aducanumab, don't do anything really for cognitive enhancement, although the FDA is considering approving it just for political gain. So what if A beta is there to help? And maybe it's an antimicrobial peptide. So there's a process called opsonization. You can do it with antibodies where there's a pathogen or some other problematic molecule like a protein aggregate. It gets surrounded by antibodies or by A beta, and that attracts immune cells such as NK cells to come eliminate it, and that solves the problem. So it's opsonization, it's a neutralization mechanism. Some work from Rudy Tanzi's lab and others shows that A beta peptide actually ensnares and encapsulates and holds back microbes, including salmonella. Here you can see these fibrils capturing and trying to neutralize salmonella, as well as agglutinating candida. If you eat too much sugar, candida accumulates as well. So A beta is an ancient protein. It's found for hundreds of millions of years in very distant genomes of various organisms. So it's obviously doing something important. It did not evolve just to cause Alzheimer's, right? It's something going wrong. So these microbes, where are they coming from? Well, one theory is some come from the mouth, gingivitis causing microbes. There's a company that was a very successful IPO a couple of years ago, Cortexime, developing small molecule inhibitors of a gingipane protease produced by one of these microbes. I actually don't think that will work, but it's gotten a lot of attention as a new approach to Alzheimer's. But another good one is the gut, for the reasons that I mentioned previously. And why the gut? Well, it is the interface with the immune system in the outside world to a large extent, and it's very fragile. It's only one cell layer thick. The intestinal epithelium is only one cell layer thick. Fortunately, it's very proliferative, so you can replace damage relatively quickly. But if there is breakage and interruption in that one cell layer thick, you've got a problem. So what can we do about it? Well, this is a kind of surprisingly underdeveloped area of drug discovery. I mean, for the last several years, I've been scouring the world for therapeutic approaches, and I've rarely come across approaches for restoring and enhancing gut barrier integrity. But one that I've come across recently is this protein called intestinal alkaline phosphatase, IAP, that comes out of the lab of Richard Hoden, who's the head of gastroenterology at Mass General and Harvard Medical School. He's a lovely guy. We have come up with ideas on how to advance this molecule in the clinic and partnered it. It's been partnered with an existing company who looks to be interested in advancing this protein. Anyway, so why is this of interest? It's backwards. All right, it's produced in the gut. Its levels decline with age. It's produced in mother's milk to train the immune system. It modulates the gut microbiome. It enhances gut barrier function, proliferation. It's already worked in a small clinical trial in ulcerative colitis previously. And most interesting for me as being a geroscientist is it extends mouse lifespan by 30% median with no apparent side effects. This is the world record for lifespan extension. And other drugs that do extend lifespan like rapamycin, metformin, et cetera, they do have side effects. So this is a very interesting approach, and I'm working on trying to get that in the clinic ASAP. Another interesting area is neurotropic viruses. I'm not an expert in this, but this is a hot area and it's not new. So to my knowledge, there are no beneficial viruses. Some microbes like bacteria are symbiotic, but to my knowledge, all viruses are either commensal, they don't do anything bad, or they're actively pathogenic. Some viruses infect the nervous system selectively, the herpes group, picornaviruses, rabies, measles, mumps, rubella, and even HIV has tropism into the brain. Another one that is relatively understudied are these endogenous retroviruses or transposons. These are strongly implicated in aging and brain aging, and we can come to that later. One of the pioneers in this field who had been criticized for many years until it was proven that, looks like she's right, is Dr. Ruth Idzaki. She's currently or was recently a visiting fellow at Oxford, so you can go visit her there. She found HSV in AD patient brains a long time ago. Many studies have found a link, and you can follow up on this research and some of these reviews by Dr. Idzaki. So this is herpes simplex virus. Almost everybody has it, and almost everybody has a lot of different viruses, many viruses we have never even defined, but our immune system is strong enough to keep them in check. Just like usually our immune system is strong enough to keep cancer in check. So the question shouldn't be, what virus is causing the disease. It should be what is causing the failure of your immune system to hold at bay these pathogens. So it is a little bit of a controversial field in dementia. Some studies have found a link, so others haven't. I tend to believe that there is a link. It may be a specific subtype. In fact, I'm quite sure it's a specific subtype of Alzheimer's that is caused by pathogens, including HSV. And, you know, it could just be that the HSV presence is a secondary side effect of the failing blood-brain barrier or immune system. So the HSV is not the primary cause, but it's just sort of a readout on the integrity of the blood-brain barrier. Nonetheless, there was a very large study finding that if you give patients who are taking anti-herpes simplex virus drugs, small molecules, they have a 2.5x reduced risk of Alzheimer's disease. It actually reduces your risk of Alzheimer's back to baseline, which is quite compelling. So it's worth investigating further. As an interesting development, I guess I'll throw this out for my my advisor at Oxford, who is an expert in DNA damage repair. There's actually a link between brain aging and memory and learning and DNA damage. And it's not what you would expect, and it surprised me, which is we require DNA double-strand breaks in order for memory and learning to occur. DNA double-strand breaks are usually a pretty big deal in the cell, pretty bad, cause apoptosis. CRISPR causes DSBs. That's a drawback with CRISPR and why the nicases are more interesting. But several labs have now found, including the Li Hui Sai lab at MIT, that these breaks are actually critical for memory and learning. They're a switch that turns on early response genes and synaptic plasticity and requires topoisomerase 2b beta. And in neurodegeneration, these DSBs are not repaired. They accumulate and they cause inflammation and apoptosis. So I mentioned these subtypes of Alzheimer's. Dale Bredesen is one of the leaders in this field. He was trained at Duke, UCSF, and Caltech, and he's a professor at UCLA and was at the Buck. And he has come out with his book, The End of Alzheimer's, that details these hundreds and hundreds of patients that he and others have actually helped better than any other intervention known with Alzheimer's. And it's not a single drug. Unfortunately, it's not that easy. It's a pretty radical change to diet, lifestyle, and taking a lot of supplements, including B vitamins that are missing, and clearing out toxins from the brain, including mercury and other such insults to the brain. So, so definitely check out this work, and I think it's going to get a lot of attention soon enough. And we covered some of these mechanisms previously. Brain energy metabolism is a really appealing